So next up in level 7.4, we're going to talk about the sum and difference formulas. These come into play when we have addition or subtraction inside our trig function. And the main ones that we focus on are cosine and sine. There are also sum and difference formulas for tangent, but we will not be covering those. They are just a little more extraneous than we need to. So I'm going to try and give you the easiest way to remember these formulas, even though I will give you them. It's important that you kind of know which ones to use. So with cosine, if we have the sum of two angles, we do the opposite sign. So cosine with sum or difference, we're going to change the sign, or cosine changes. C, change, cosine changes. And then it goes cosine A, cosine B, minus sine A, sine B, or vice versa. Cosine A, cosine B, plus sine A, sine B. So cosine, you can say quickly. So cosine, sine. That's how I remember cosine formula. So the sum of two angles, cosine, sine, cosine changes signs. So what do we mean by that? Well, if you have the cosine of 75 degrees, we don't know this. This angle is not on the unit circle, but we can make this seem like it's an angle on the unit circle by saying the cosine of 75 is the same thing as the cosine of 45 plus 30. Well, now that we have two different angle measures, this is the sum of two things. So we can use the sum formula for cosine. So it would be cosine 45 times cosine 30. Cosine changes, so minus sine 45 sine 30. So cosine 45 degrees, we know that is the square root of 2 over 2 times cosine of 30 degrees. The cosine is square root of 3 over 2 minus sine is root 2 over 2 minus sine 30, again, hand trick, which is 1/2. So this becomes root 6 over 4 minus root 2 over 4, or root 6 minus root 2 all over 4. And if you want to check, you can see that that is the exact same thing as what your calculator will tell you in exact form. Okay, with B, cosine of 15 degrees, we could say that's the cosine of 45 minus 30. Okay, you see that we're using the unit circle. So cosine of 45 minus 30 is cos 45 cos 30. Cosine changes, so plus sine 45 sine 30. So cosine 45, again, root 2 over 2. Cosine of 30, again, is root 3 over 2 plus root 2 over 2 times 1/2. So this gives us root 6 plus root 2 all over 4. So the only difference between 15 degrees and 75 degrees is the sign in between. Last up, so this might be a little tricky for you, pi over 12. Well, we don't really have nice measures for pi over 12, but we do know pi over 6ths is if you took pi over 3, which is, we want to get a denominator of pi over 12, or we're cutting pi over 6 in half. So the easiest way to do this is we need a common denominator. If we took a fourth minus a sixth, well, a fourth is 3 pi over 12, and a sixth is 2 pi over 12. So if we have 3 pi over 12 minus 2 pi over 12, we get pi over 12. Those are our fraction work for us. So the cosine of pi over 12 is the same thing as the cosine of pi over 4 minus pi over 6. Now if you're saying, well, that's just the exact same formula that we did for the cosine of 15 degrees. And you are absolutely right. We can easily do either one of these. So cosine pi over 4, cosine pi over 6 plus sine pi over 4 sine pi over 6, which again will give us root 6 plus root 2 all over 4. These are the exact same angle, cosine 15 degrees, cosine of pi over 12. The next set of formulas, the sum or difference of sine functions. So if we are adding two angles together or subtracting, the easiest way I can give you to remember sine is that if we have sum, it's a plus. If we have subtraction, it's a subtraction. So sines stay the same. Cosine changes. So sines stay the same. Cosine changes. And sine is slow versus cosine being quick. So to say the sum or difference formula for sine, it's slow. So sine, cos, sine. Let's do that again. So sine is slow, so we go sine, cos, sine. Versus cosine of the sum or difference is quick, so cos, sine, sine. Hopefully some of these will help. I will definitely say them again in class if we need them. Okay, so the sine of 7 pi over 12. Again, we don't have a really good angle measure for this, but if we had, let's say, pi over 4 plus pi over 3. Well, pi over 4 is 3 pi over 12, and pi over 3 is 4 pi over 12, so that would give us 7 pi over 12. So this would be the sine of pi over 4 plus pi over 3. So sine is slow, so sine, cos, sine, cos, sine stay the same, so plus cos of the first angle, sine of the second angle. Sine, cos, sine. All right, cosine of pi over 4, root 2 over 2. Cosine of pi over 3, 1/2, plus cosine of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. So this gives us root 2 plus root 6 all over 4, which is the same as the cosine of pi over 12. Okay, cosine of 165. Now there's a bunch of ways you can get to 165, but for our case, let's just pick a different color. I'm going to say this is the sine of 135 plus 30. Could you also do a couple other ones? Yes. I think this is the easiest route. So sine, cos, sine. So sine 135, cos 30. Sine stay the same, plus cos 135, sine 30. So the sine of 135, that's a 45-degree angle in the second quadrant, so that's root 2 over 2. The cosine of 30 is root 3 over 2, plus cosine of 135 is negative root 2 over 2. The sine of 30 is 1/2. So we get root 6 minus root 2 all over 4. So not quite precise as the other ones, but we can find these approximations. Okay, finally, sine of 75 degrees. We're going to do sine of 30 plus 45. It doesn't matter what order we put these in. So this would be sine 30 cos 45 plus cos 30 sine 45. So sine of 30 is 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. So we get root 2 plus root 6 all over 4. sine of 75 degrees. All right, let's flip it over. Try a couple more. So with example 3, just like we could go forwards and separate some angle, an angle that we don't know, into angles that we do know on the unit circle, likewise, we can go backwards. So I can give you this expansion and say, well, what is the exact value of this angle? So if we look at this formula, sine 80 cosine 20 minus cosine 80 sine 20, that is the difference formula for sine. Sine, cos, cosine. So this is sine of 80 and 20, and signs stay the same. So really this is saying, what is the sine of 60 degrees? So sine of 60 is root 3 over 2. So this big old expression is really just a simple question that you know how to answer since level 6. Okay. Example 4. This is where our knowing how to draw triangles comes back into play. So we have 2 different triangles, and it's important to know that we have 2 different ones. So I'm going to draw a triangle for alpha, and it says alpha is between pi over 2 and pi. So A are angles in radians already, and that tells me I am in the second quadrant. Over here, I'm going to draw my triangle. This angle, beta, is in the third quadrant. And this is their angle right here. We could say that goes all the way around here. This one goes all the way around here. These 2 are equivalent. Okay, so with alpha, let's start here. Sine is opposite over hypotenuse. So that means that this third side, if I remember my Pythagorean triples, is -3. We could do the Pythagorean theorem if you want. This is what it works out to be. So if I want to know what cosine of alpha is, cosine alpha is equal to -3 over 5. With beta, I'm in the third quadrant. Sine is opposite, so -2 over root 5. So I have to find this third side. So that is x plus 4 equals 5, or x squared. X squared equals 1. So this is -1 because it's in the third quadrant. It's super important that we know the directions that we're going in. Otherwise, our signs get mixed up pretty quickly. So cosine beta is adjacent over hypotenuse, -1 over the square root of 5, or just to clean it up, this is -5 over 5. Just to clean this one up, it's -2 root 5 over 5. Okay, why do we do all of this? These are the first 2 parts. It will help us for cosine of the sum and cosine and the sine of the sum. So cosine is quick, and cosine changes. So we have cos minus sine. That's our formula. So the cosine of alpha is -3/5. The cosine of beta is -√5 over 5 minus sine alpha 4/5 times sine beta -2√5 over 5. So this gives me negative times a negative is a positive. So this is 3√5. Negative times a negative is a positive. This is 8√5 all over 25. These are common, so I can add those together. I get 11√5 over 25. With sine is slow. Let's do this in a different color. So I'm going to write it out first. It's sine alpha cosine beta. Sine stay the same. Cosine alpha sine beta. Okay? Sine of alpha, 4 over 5. Cosine beta, -√5 over 5. Plus cosine alpha, -3 over 5. Sine beta, negative 2 root 5 over 5. So this would give me negative 4 root 5 plus 6 root 5 all over 25, which gives me 2 root 5 over 25. And that is the exact answer for these two triangles. I know these are difficult. I know you have to draw two pictures out. So really, take your time. This is kind of the culmination of a lot of things we've been doing since level 6. Last question. You can't get through one of these sections without doing at least one proof. So, establish the identity. Again, we're going to look on the left side. Left side says cosine alpha minus beta. Well, cosine is quick, so that's cosine changes plus sine over now, the tricky part is when we only have one thing in the denominator, we can write this as cos alpha cos beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta. Well, these all cancel off and just become 1. Cosine over sine is cotangent alpha. Cosine over sine is cotangent beta plus 1, which is exactly what we wanted. Okay, hopefully this has made sum and difference formulas a little bit easier. Once you get the hang of it, they actually are quite easy. We have one more section, and that is half angle formulas. And then we are done with level 7.